Welcome to the deep dive. Today, we're diving into some really cool AI research.
Oh, yeah.
Yeah,
Good.
specifically how researchers are making language models even more powerful
Okay.
without needing to train them on massive amounts of data.
Interesting.
Like, imagine trying to solve a complex math problem, but you only have like a single sheet of paper with just the essential formulas.
Hmm.
That's the kind of efficiency we're talking about here.
So that's like getting more from what we already have.
Yeah, exactly. Squeezing more juice out of the lemon, so to speak.
I like that.
So what's fascinating is this research challenges the assumption that bigger is always better when it comes to AI models.
Well, it turns out that with careful selection and some clever techniques, we can achieve some remarkable results with a surprisingly small amount of data.
Okay, I am intrigued.
Yeah.
Tell me more about this research and this model they're using.
Okay, so the model is called S132B.
S132B.
Yeah, and it's achieving performance levels comparable to much larger models, but using a fraction of the resources.
That's amazing.
Yeah, and one of the keys to its efficiency is this really meticulously curated dataset called S1K.
S1K.
Right.
So just 1,000 examples.
Yeah.
That's incredibly small compared to the massive data sets we usually hear about in AI training.
Exactly. But the researchers didn't just randomly select these examples.
Okay.
They focused on three key criteria: quality, difficulty, and diversity.
So almost like building like an all-star team for a trivia competition.
Exactly. You want players with accurate knowledge who can handle tough questions and who have expertise in a range of subjects.
I like that analogy.
Thanks.
So how do they apply this all-star team concept to building a data set for an AI model?
Let's take a look at one of the sources they used: a collection of brain teasers
Oh, fun.
designed to challenge even the sharpest minds. Imagine this problem. Alice and Bob each have a coin and flip it until they get heads. If Bob flipped his coin more times than Alice, what is the expected number of times Alice flipped her coin?
Oh, that's a classic probability puzzle. It makes my head spin just thinking about it.
Right. And now imagine giving that puzzle to a language model.
Okay.
Not only would you include the problem and the correct answer, but you would also provide a step-by-step solution,
Got it.
a kind of thinking process
Uh-huh.
generated using advanced tools.
So instead of just memorizing the answer, the model is learning how to approach the problem,
Yes,
break it down, and arrive at the solution logically.
that's right. And by selecting examples like this high-quality, challenging, and diverse kit, they created this incredibly potent data set, S1K,
Okay.
that allows S132B to punch way above its weight.
That's incredible. But we also talked about test time scaling as another key to this model's efficiency. What exactly does that mean?
So test time scaling,
Yeah.
it's a fascinating concept.
Mm-hmm.
Essentially, it's about finding ways to boost a language model's performance
Okay.
without retraining it from scratch,
Right.
which can be very time-consuming and expensive.
Yeah, of course.
One technique they're using is called budget forcing.
Budget forcing. Okay, I'm picturing some kind of financial spreadsheet for AI.
Think of it this way. Imagine taking a difficult exam.
Okay.
Some questions you can answer quickly,
Yeah.
while others require you to pause, consider different angles, and work through the logic carefully.
Mm-hmm.
Budget forcing is like giving the language model that extra thinking time for those tougher problems.
So instead of rushing to an answer, it has the space to explore different possibilities.
Exactly.
Make connections and arrive at a more well-considered solution.
That's a really good way to put it. And what's interesting here is that it suggests a different approach to problem solving,
Uh-huh.
one that is perhaps more deliberate and methodical than we might typically associate with AI.
Yeah, interesting.
That's like giving the model the opportunity to be more thoughtful.
That's really fascinating. So by combining this potent S1K dataset with techniques like budget forcing, they're able to unlock a level of performance in S132B.
Right.
That's comparable to much larger resource-intensive models.
Precisely.
Yeah.
And this research raises some really interesting questions about the future of AI development.
Yeah.
If we can achieve such impressive results with smaller, carefully curated models,
Right.
it could have significant implications for accessibility, efficiency, and even the way we think about intelligence itself.
This is all incredibly exciting, and I'm eager to dive deeper into the implications.
Yeah.
But before we do, I'm curious about something. You mentioned other test time scaling methods.
Right.
Are they all as effective as budget forcing?
That's a great question. And it leads to a somewhat surprising finding. It
Hmm.
turns out that some seemingly intuitive methods for boosting performance can actually backfire.
Oh, really?
Yeah, one example is rejection sampling,
Okay.
where you essentially keep generating solutions until you find one that fits within a certain compute budget.
So I would think having more options to choose from would lead to better outcomes.
Yeah, you would think.
Why wouldn't that work?
It's a bit counterintuitive. But the research suggests that there might be a correlation between shorter generation attempts and being on the right track from the start.
Interesting.
If the model is able to quickly generate a solution, it might indicate a deeper understanding of the problem.
So it's like that student who confidently raises their hand right away because they know the answer
Right.
versus the student who's second-guessing themselves and taking a lot longer to work through it.
Exactly. It highlights the fact that we're still unraveling the mysteries of how these language models actually think and learn.
So budget forcing seems to be a promising approach, but are there any limitations to how far we can push it?
That's an important point.
Yeah.
Even with budget forcing, there are limits to how much thinking time we can effectively give the model.
Okay.
At a certain point, you start seeing diminishing returns,
Uh-huh.
where increasing the budget doesn't lead to significant performance gains.
So it's like there's a point where giving the model more time to think doesn't actually lead to better insights.
Yeah, exactly. And another factor to consider is the model's context window,
Okay.
the amount of information it can hold in its memory at any given time.
Right.
If the solution requires a very long and complex thought process, it might exceed the model's capacity to keep track of everything.
It's like trying to juggle too many balls at once.
Yeah.
Eventually you're bound to drop a few.
Precisely. So while budget forcing is a valuable technique, it's not a magic bullet.
Got it.
Researchers are also exploring other methods, particularly parallel scaling approaches, to overcome these limitations.
Parallel scaling, what's the difference between that and something like budget forcing?
Imagine you have a complex problem to solve
Okay.
with budget forcing. It's like having one really smart person working on it,
Okay.
and you give them more and more time to think it through.
Mm-hmm.
With parallel scaling, it's like having multiple teams working on the problem simultaneously,
I see.
each exploring different approaches.
So it's about harnessing the power of multiple perspectives and approaches.
Exactly.
Yeah.
And one particularly promising approach is tree search, with a technique called rebase. It's like having a master strategist guiding those multiple teams,
Okay.
helping them prioritize the most promising avenues and avoid dead ends.
So it's about combining the focused thinking of budget forcing
Right.
with the power of multiple perspectives from parallel scaling. It sounds like a powerful combination.
It certainly does. And the early results suggest that these parallel scaling methods can be highly effective,
Okay.
especially when dealing with very complex problems that require a lot of computational power and creative problem solving.
This is also fascinating. It really highlights the incredible ingenuity and dedication of the researchers who are pushing the boundaries of what AI can do. But I'm also curious about the bigger picture.
Yeah.
What are the implications of these advancements?
Mm.
Where is all of this leading?
That's a great question.
Yeah.
And I think it's important to step back and consider the broader context. For one thing, this research suggests a shift away from simply building bigger and bigger AI models. Efficiency is becoming increasingly important.
It's not just about brute force anymore.
Exactly. It's about being smarter with our data and algorithms. If we can achieve these remarkable results with a model trained on just 1,000 carefully selected examples, imagine what might be possible in the future with even more targeted and strategic approaches to data selection.
It's like we're moving from a quantity over quality mindset to a more refined, almost artisanal approach to training AI models.
I love that analogy. It really captures the essence of this shift, and it opens up exciting new possibilities for democratizing access to AI.
In what way?
Well, if we can train powerful models with less data and fewer resources, it means that researchers and developers with limited budgets can still make significant contributions.
That's a huge win for the advancement of AI. It levels the playing field and allows for a greater diversity of perspectives and approaches.
Absolutely. And this research also underscores the importance of open science in this rapidly evolving field. By openly sharing their methods and findings, these researchers are fostering collaboration, accelerating progress, and ensuring that the benefits of these advancements are widely shared.
I couldn't agree more. Open science is crucial, especially when we're talking about technologies with such profound potential impact. But with that impact in mind, it's also important to talk about the potential risks and ethical considerations.
Yeah, definitely.
As these language models become increasingly powerful and sophisticated, how do we ensure that they are used responsibly and for the benefit of humanity?
That's perhaps the most crucial question of all, and it's one that we'll need to address as a society as we continue to explore the frontiers of artificial intelligence.
This deep dive has been incredibly illuminating, and I'm walking away with a much deeper understanding of the remarkable progress that's being made in the field of AI. But before we wrap up, I'd love to hear your perspective on the most significant takeaway from this research.
Okay.
What stands out to you as the most important insight?
For me, it's the realization that we're moving beyond the era of just scaling up models
Right.
to a more nuanced approach
Uh-huh.
that emphasizes efficiency,
Okay.
strategic data selection, and test time optimization.
So this shift,
Yeah,
it has the potential to democratize access to AI,
exactly.
accelerate progress, and unlock even greater problem-solving capabilities.
Right. And as you said, it raises some really interesting questions about the very nature of intelligence.
Yeah, it's not just about raw processing power,
Right.
but also how effectively information is used and organized.
It really challenges our assumptions about how intelligence works,
Mm-hmm.
both in machines and in humans.
Yeah.
If we can achieve remarkable results with AI models by carefully selecting and organizing information,
Right.
what does that imply about the potential of our own minds? Are
Wow.
we just scratching the surface of what's possible?
It's mind-blowing to think that we might be able to unlock new levels of creativity
Yeah.
and problem solving by simply finding better ways to tap into the vast potential that's already within us.
Like, if we connect this to the bigger picture,
Yeah.
it raises a really important question about the future of education and learning.
Okay.
If AI models can achieve remarkable results with carefully curated examples and targeted training,
Right.
what does that mean for how we teach and learn as humans?
It's like this research is giving us a glimpse into a more efficient
Right.
and personalized approach to education,
Yeah.
tailored to individual strengths and areas for growth.
Exactly. Imagine a world where learning is less about rote memorization
Yeah.
and more about understanding the underlying principles and developing the skills to think critically and solve problems effectively.
That's a future I can definitely get behind.
Me too. It's
Yeah.
about cultivating genuine understanding and wisdom,
Right.
not just accumulating facts and figures.
Exactly. And as we continue to unlock the potential of AI, we can learn valuable lessons about how to unlock our own potential as well.
That's a great way to put it. It's a journey of discovery and collaboration,
Yeah.
both between humans and machines
Mm-hmm.
and between humans ourselves.
This deep dive has been an incredible reminder that we're living in an era of unprecedented technological advancement,
Yeah, for sure.
but it's also an era that demands thoughtful reflection on the societal impact of these innovations.
I couldn't agree more. As we push the boundaries of AI,
Uh-huh.
we must do so with a sense of responsibility,
Right.
ensuring that these powerful tools are used to create a brighter and more equitable future for all.
Well said. This has been an incredible deep dive. Thank you for sharing your expertise and insights.
Of course, it is my pleasure.
I can't wait to see what breakthroughs emerge next in this rapidly evolving field.
I know, me too.
Thanks for joining us on the deep dive. We'll be back soon with another fascinating exploration of cutting-edge research and ideas. Until then, keep learning, keep questioning, and keep diving deep.